In this lesson, you will learn what expression language is, where it can be used, and how it helps you dynamically process and transform data within a data flow. In enterprise data environments, the ability to dynamically transform and control data is critical. Business rules evolve, data formats vary, and decisions depend on how effectively data can be processed in real time. To meet these demands, organizations need a flexible way to apply logic and adapt data as it moves through systems, without constantly redesigning data flows. That's where expression language in real-time streaming within data integration becomes essential. Let's begin with the fundamentals. Expression language is used to create expressions that evaluate or modify data within a data flow. It is based on the JSP expression language and enables you to define dynamic values, conditions, and transformations directly within stage configurations. You can use expressions in stage properties, data flow properties, conditional logic, and even in certain target configurations. This flexibility makes expression language a key capability for building intelligent, adaptive data flows. Now that you understand what expression language is, let's look at how it works. All expressions follow a simple and consistent syntax. They begin with a $sign and are enclosed in curly brackets. Given is an example. This evaluates to 4. This structure allows you to define both numeric and string-based operations in a consistent way. With the syntax in place, let's explore where expressions can be applied. Expression language can be used to define numeric values, string values, conditional logic, and field-level selections. For example, you can use it to route records, configure stage properties, or dynamically assign values. However, expressions are not supported in every field. Their availability depends on the specific configuration property. Next, let's look at the building blocks used within expressions. Expression language supports several key elements. These include constants, field names, functions, operators, runtime parameters, and date or time variables. Each element plays a role in helping you define how data should be processed. It's important to remember that only valid elements for a specific field can be used in that context. To make working with these elements easier, the platform provides a helpful feature. Expression completion helps you build expressions faster and more accurately. It allows you to see whether expressions are supported in a field and shows you the valid functions, fields, and parameters available. To use it, place your cursor in a supported field and press Ctrl plus space. If suggestions appear, expressions are supported. If not, they are not available in that location. You'll also notice icons that help identify different elements. A C represents constants, an F represents functions, a square icon represents fields, and X represents runtime parameters. These visual cues make it easier to build expressions quickly. For more information, visit the documentation portal to explore additional details. Now, let's look at how functions work within expressions. Expression language includes a rich set of built-in functions. When you insert a function, it appears with placeholders that guide you on how to use it. Functions can be used for string manipulation, mathematical calculations, date and time processing, and more. With these capabilities in mind, let's explore a few practical examples. You can use expression language for conditional routing. For example, record value name contains John. This routes records where the name field value contains John. You can also handle empty fields by checking if a value is blank. And you can route records based on error conditions using error codes. These examples show how expression language enables dynamic and intelligent data processing. Now let's bring it all together. Expression language allows you to apply logic directly within your data flow. This means you can transform data in real time, apply business rules dynamically, and reduce reliance on external processing. The result is more efficient, scalable, and maintainable data integration. You've now learned the fundamentals of expression language and how it enables dynamic data transformation within a data flow. In the next video, we'll move from concept to practice and walk step by step through real use cases, helping you apply these ideas in a real implementation scenario. Let's continue to the next lesson and start building